Alright class, we're going to talk about the equation of a central angle equating to an arc length being divided by the radius of a circle. We'll start by defining the radius. The radius is the point in the center of the circle out to an edge. Whatever distance that is, that's the radius. Now let's say that radius line was to rotate through the circle to, let's say here, the angle of rotation is called, this angle is called the central angle. And we use theta to describe the central angle. Now, the length of the arc in which that angle rotates, that is called the arc length. So that red line there is the arc length. This is the central angle and the radius. Okay, so here I've written the equation where this is the central angle in radians. This is in cursive, this is an AL, the arc length, and the R is for the radius. Alright, so you're given the information, let's say that the radius of the circle is 3 and the arc length is 2 pi. And of course the question will be, what is theta? And so according to our equation, theta is going to equal the arc length, which is 2 pi, divided by 3. And so the answer is 2 pi thirds. And that makes sense. If you recall that halfway along the radians, the angle of radians is pi, then that spot right there does look like about 2/3 of pi. Okay, say this is the next problem you're given and you're told that the arc length is 20 pi. You're asked for the radius and the angle of rotation is pi fourths. Alright, so of course remember that we have the angle in radians equals arc length divided by the radius. Now I need to get r all by itself, so from this equation I'm going to multiply both sides by r, and that gives me r times the angle of rotation, and over here the r's cancel, so that just equals the arc length. Dividing both sides by the angle of rotation, I get that this is the radius. Okay, so here I end up with a fraction in the denominator, and so the denominator of that denominator, whatever it is, it pops up to the top. And so I end up with a 4 times 20 times pi all divided by pi. And with the pi's canceling out, I get 4 times 20, which leaves me with a radius of 80. And just kind of analyzing the problem, if we look at the angle of rotation, we could see that it's pi fourths. Notice where pi fourths is. Take a look at the arc length. It's 20 pi, which equates to a little bit more than 60. Alright, so if that distance is 60, and you figure that there are 8 of these sections in the circle, 8 times 6, somewhere around 480 around, and that distance there is something like 60. And again, we get a radius of 80. Okay, here's our next problem. In this one, we're going to be asked to find the arc length. The radius is marked 10 for us. Now, the angle of rotation is 3 over 2 pi halves. Now, here you have to recall your unit circle. And so the angle of rotation is 3 over 2 pi. Again, this is something you have to know your unit circle to be able to find that spot. Alright, so in this question we're basically being asked, what is the length of the red line? That is the arc length. Okay, and so here's our equation, and we want the arc length, so we have to do a little math. We have to multiply both sides by r, and so multiplying both sides by r, we get the arc length equals the angle of rotation times the radius. And that gives us 3 over 2 times pi times 10. The 2 and the 10 will cancel to a 5. And so I end up getting a length of 15 times pi. So that's around 46-ish, maybe 47, a length of that. Okay, now for the more challenging problem of the quiz, I'm going to give you 2 things on a circle. I'm going to give you the circumference of the circle, and I'm going to give you the angle of rotation in radians, and you will have to give me the arc length, or as I've been calling it, the AL. So I'm told that the circumference is 16 pi and the angle of rotation is pi. Now you have to do some intuitive thinking on this. You have to say, well, the angle of rotation is pi. Hopefully, again, you'll know that that angle rotates the radius to here, pi, right? All the way around is 2 pi, so halfway is going to be pi. So there's our angle of rotation. And so there is my arc. Now, just looking at it, and again, here's where the intuitive part of this question comes. Knowing that the entire circumference is 16 pi, and looking at my arc and seeing that it only is halfway around the entire circle, I should be able to conclude that the arc length is half of the entire circumference, which is 16 pi, so I get 8 pi for the arc length. Okay, and for a final problem, this will be about as difficult as it gets. It'll be the same thing. I'll give you the circumference, and I will give you, this is the information given. The circumference is a distance of 24. The angle of rotation is 11 pi sixths. Okay, so by writing in the radius and putting in the rotation, here's my angle. Again, it's 11 pi sixths, so you should know it's here. Now at this point, you have to realize, okay, the distance all the way around the circle is 24. And the arc length is what we're looking for. All right, so there is there. So again, the circle is 24. The arc length that we're looking for is that distance. It's 11 sixths pi around the, that's the angle of rotation. Now, the intuitive part here is noticing that that distance around is going to be a total of 11 twelfths of the whole distance. That comes from the fact that this whole circle can be broken up into 12 sections of these here. Again, looking on your unit circle chart, you will see that pi sixths, there are 12 sections of pi sixths, and that's what this is. So I get that the arc length is 11 twelfths of the entire circumference. Canceling my 24 and my 12 to a 2 and a 1, I end up with an arc length of 22. And that makes sense. If the circumference is 24 and that's my arc length, it looks like it'd be about 22.